it's National, you know, wear a culturally insensitive, I guess, face mask today. No, it's not. It's my shemagh. You like it? I do. So hey, today we're going to talk about arguments in the C language types. You know, sometimes it's important to introduce, I guess, arguments to a program so you don't have to open up the program, hard code a new variable or something, get new output, because also sometimes you just want to kind of feed an entire file into a C program. You can kind of have control over the data type, you can have control over how many arguments you want. And what I'm referring to, this kind of came up in a conversation a little bit earlier today with somebody. What I'm referring to is, have you ever seen the C, just any C program, and you see that long, like int main, huge long thing? I kind of just want to explain what that was. It's got a purpose, it's got a point. It doesn't do anything if you just blow by it, or you could just do, you know, int main, you know, no argument for anything. But you should know, because this is very useful. As well, I kind of wanted to bring to the point, or bring to your acknowledgement that, you know, you can mix and match. It's probably not good practice to, but you can totally get away with it. If you've got some C language thing that you want to implement inside of your C++ program, it's totally legal. Again, purists hate it, but it totally works because one was built out of the other. And so very first, I suppose, let's just get started, and I'll show you kind of what I'm talking about. So let's touch script. Let me go here. Okay, go to insert mode. So right off the bat, you know, we need our preprocessor or our library references. So we'll go, and as you remember, IOStream. This deals with our 3 different types of places for things to go. You know, screen, in, out, error. You know, and here's another one that maybe you've seen before, and I know I mentioned a little bit earlier, in that whenever you see a .h library, sometimes it's referring to an earlier compiler type, so it's a good indication that there might be some C type things going on in the program. So in this case, we're going to use the same. So IOStream is a library that deals with file management of IO, in out. So now we've got stdio.h. Same functionality, pretty cool. Good stuff. So then we'll go, of course, this is our mix and match of our C language stuff. So what the heck are you talking about, Sean? So int main int. Tell me if you've ever seen this. There. So let's talk about this very strange looking thing. Okay, so as I said, you know, it's possible to pass some values from the command line to your C program when they're executed. These values are called command line arguments, and many times are important for your program, especially, you know, when you want to control your program from the outside instead of having to go back in and hard code some variable, as I said. Now, what do these things mean? So the command line arguments are handled using the main function arguments, where, so these are the main function arguments. Everything inside the parentheses is considered an argument. See, there's a little comma, so that means argument. How should I say this? So we need to figure out what the program is called, how many arguments are going to be passed. And so specifically, like an argv array, this guy right here, it's a pointer array, which points to each argument that's passed to the program. So I guess I'll kind of keep going. Maybe this will kind of make more sense. It should be noted that, an arg, I guess an arg0, I guess I should talk about that because I don't know how many of you actually know this or not. But so when you're dealing with an array, which is kind of what this is, array counting, at least in these C languages, this isn't for all languages because I don't know if Ada does or some of the other ones, or Fortran. Anyway, you're going to start your array counting with 0. So 0 is the first element in any array, that we're dealing with. 1 would be the second element, 2 would be the third element. Okay? So this is important because the 0 element, which is the first element in an array, is going to be reserved in this circumstance for the name of the program. Any follow-on arguments that we pass to the program are going to be dropped into the array as they're put in as arguments. And so what that means is this pointer, this argc, is the number of arguments. This char, so this means I'm going to have a char type point at all of these different argument elements, right? So I don't know if that makes any sense to you at all, so maybe we'll just try to demonstrate it. Again, so the argc, it's considered arg count, this guy. Okay? It is, I guess, I don't know. It's an int. It stores the number of command line arguments passed to the user, passed by the user, including the name of the program. Again, so if we pass a value to the program, the value of argc would be 2, one for the argument and one for the name of the program. The value of argc, of course, should be non-negative. This is kind of a default. So the argv, this guy, is considered the argument vector. It is an array. Now, I don't know if you probably don't. So a vector is basically a resizable array. As C needs more space, or C++ needs more space, it vectors itself. Vector is another word for array, but this kind of gives you the opportunity to build without having to go through. So argv, argument vector, is an array of character pointers listing all of the arguments. So without going into a class about arrays because it's a data structure, or vectors because it's a data structure, you need to understand that this is kind of what's going on. We'll get to it, okay? If argz, or argc, this guy right here, if that is greater than 0, the array elements from arg0 to argv, which is argc minus 1, I don't know if you're going to understand that, will contain pointers to different strings. String data type. So argv0 is the name of the program. After that, I don't know if you understand. So if we have an array of n numbers, I'll just say numbers, right? The total number of elements in the array, of course, will equal, if we just count them, 0, 1, 2, 3, so equals 4. Equals 4 elements, right? But if you're wanting to get to kind of what's what here, or what the end of it is, we know that we have 4 elements here, right? But we want to point at the very last element, which is 3. So I can't say, well, we're just going to go to the 4th element. So because it's not called that, it's called 3. So what you would refer to it as is number of elements minus 1, if that makes sense. So n minus 1 is the final or the last argument. take a computer science beginning class. You'll talk about that for maybe a week. But this is part of the structured programming, I think, that a lot of, these other silly courses sort of gloss over. Not that I'm doing a great job. Anyway, enough of that. So let's do a quickie little demo. So here we got this, stuff. I guess we can just kind of put in some other business so that you can, so arg0, argv0 is the place where the name of the program is going to get stored. So arg2, whatever, that's where all your other arguments are going to be. So let's do a little printf statement. So this is kind of interesting. See, before we were dealing with cout, to print something on the screen. Check this out. So I'm going to use this. This printf is a function called from the stdio, standard inout.h library from the C language type. And it's going to say printf string, which is this, okay? This space holder, which is what it is, this percent, data type S, data type string, is going to end up going, and then of course the argument. Okay, so argv0 is the name of the program. Okay, so in this case, script cpp is going to get copied into this placeholder, which is going to take place starting at that, whatever, I want to call it a modulo, but the percent. The escape n is just an n line carriage return. So printf, the program name is, so when we compile this program, it's going to say, okay, cool, I'm going to run this, and I'm going to grab what the name of the program is, I'm going to stick it in, even though it already does that, but I'm going to print out what this actually is. So high five. Then, I suppose, so I hope this isn't confusing. And I need to take a lesson on copy paste. So arg2 is actually the second position of the array that the pointer argv is referencing. So arg2 is just kind of, this is for us. And I'm gonna, you'll kind of understand what I'm doing here in just a moment. I'm gonna call it argument 2. Let me keep going, see if this will make sense. So let's make some string data types, right? String data types, that didn't make any sense. Let's make some string variables and then assign them something. So here, I'm going to say string A, I'm going to make, string A, string B, string C, string D. And then I'm going to assign them to argument 1, 2, 3, or 4. Now granted, if I have 4 arguments going on, there's actually going to be 5, there's going to be 5 elements in that array. It's all good and fine, I guess. So anyway, now let's just output this so it makes sense, because you'll see it compile and then it'll probably kind of bring it together. But I want you to be able to write one of these and play with it, because when you get into dealing with like really big files of like comma delineated or space delineated data, you don't always have to go to Excel. This does big data management very, very nicely if you know what you're doing. You don't have to rely on all of those tools, and this is what people did for a very long time, a long time ago. This isn't, I don't want to say this isn't rocket science, because I'm sure that there was some of that, but this is kind of it's a big deal. I don't have any return statement, I don't have anything, but so some elements again that we've got going on is right now I'm using elements of C and C++. I'm introducing the C command line argument, I guess, arguments. And then we're going to demonstrate this will be a clean compile. It's syntactically correct and all of that. And then you'll kind of see what I'm talking about. So, what did I do? Script. So let's compile this. Yeah. Okay. So now here's how this goes. Again, if you remember, I had 4 different elements that are 4 different arguments. So right now, as before, I'm just going to run the program, right? But it should give me a fault. Program name is, you remember that? Program name is, so that's the first argument. Segmentation fault means that I didn't feed it enough because I'm asking for pointers to point at stuff that isn't there because we haven't put it in. So you just have to be conscious, write your programs how you mean them. So in this case, let's do Sean. So as you see, this will be the first. So this is the program name, and then this is going to be all of the different arguments. The arguments are Sean. So I've got 4. So again, let's go back this and just kind of look at what's happening. So here, printf, blah, blah, blah. This is printing out, the name of the program, as I said. Now your string, now if I were to get rid of these, okay, so I'm in basically command mode. I'm just going to hit double D. So first argument, I don't, I'm going to get rid of this stuff. I'm going to recompile it. Oops, of course, I'm silly. Okay, sorry. Let's get rid of this guy too. Okay, so now the program named is script. It's not going to print out any arguments because I've gotten rid of that. So if I were to do Sean, it doesn't do anything because it doesn't have a place to put it. However, it's storing it as an argument. It's just not doing anything with it. It's capturing it. So let's go back. Let's fix this. I guess. And I guess we can just do this. Yeah, I don't think I want that. Busy. So we still have that going on. Now there's a lot of good resources out there that kind of talk about this, but as to why, you're never ever going to really understand it until you start messing around with it. And I'd encourage you, there's a whole bunch of big data sets out there. So the new hotness is to go get the measurement of orchids or whatever that one is, or daisies, I don't know, for machine learning. But all that comes in huge data sets. But if you were to simply write out an argument that's an I/O of a file, which is just going to be a text file, now you can have your simple C program actually run through and do something with it. Okay, so an example. So I go to ORU, yay ORU, and I had some machine learning thing that I wanted to use the text of the Bible. They're not very easy to find, where you find a no verse chapter sort of setup, just text, plain, simple, nothing but text Bible. And so I wrote a program, silly program, and it was in C, and it basically just read in the file of a text version of the King James Bible. And anytime, it just parsed through, and anytime it found a character that was something, probably a comma, I'd get rid of it. And then I'd also get rid of the space after it. And so, the output file was essentially just a really, really long array of words that was the Bible, except now it was clean. And so now I could do other things that are interesting with it, but that's not the point of this. The point is that, you get these huge, huge, huge data piles, and you can make these very simple programs that you write actually work on them. Another thing that you might consider checking out, and it kind of goes a different direction, is the Unix treatment of using already built scripts within the Unix file system, or Linux, the Unix, and piping information from one program into another program. This is kind of like what this is doing. In fact, you can do the same. You can actually do this so that you're running a program, the output of the program then pipes into some other thing that you've got going on in your operating system. Mac users can do this a lot easier than Windows users can, simply because of the file system. That's it. It's not because the computer's better. But yeah, take a Unix class if you get a chance. Kind of check that stuff out and see how it works. This is really neat stuff. Your programs are not standalone. They're not meant to be just things that you hang on a wall. They should be written for a purpose and used because they're here to make your life easier, and they're just as smart as you want them to be. Anyway, that's it. I hope this is helpful in some way. It was interesting to me. I just couldn't believe I had a conversation about it a little bit earlier. Let me grab some of this, all this other crap. You can kind of copy it or do whatever you want to do. Just do this. And let's get up here. Get rid of all of it. In this way, you'll have it. All this business. And so, really, it's just language. It's no big deal. And all this stuff is online. I'm not writing it. I'm not a genius by any means. But if you get an opportunity just to kind of read through this stuff and understand it and then write your own program, you'll see that you can start playing with these values. You could put like 2 pointers. You can put a number in here. You can change the data type that you're bringing in. It's pretty sweet. It's pretty sweet. Anyway, best of luck. Thanks. Hope that y'all have a great day. Dun, dun, dun.